Hey guys, and welcome back to another A-Level Maths revision video. And in this video today, we're going to take a look at some second year material for the stats part, which comes under basically the applied module. And in this video, we're going to take a look at the normal distribution. So I'm splitting the normal distribution up into definitely two, possibly three videos. I'm going to do a video on hypothesis testing with the normal distribution, and then I'll possibly cover another part for approximations. So in this video, it's more of an introduction to the normal distribution, being able to calculate probabilities, and just general problem solving with the normal distribution. So 4 questions in this video, all taken from the old spec. So this was from S1 paper. So I've given the year, like you can see here. So this first question here is taken from Edexcel S1, June 2010. So let's jump straight into this question. Like always, have a go at the question first if you feel like it, and then see if you can match the same solution as what I get here. But if not, let's work through this together. So what we've got here is the distances travelled to work, which is given by d kilometres here, by the employees at a large company, and they're normally distributed, and we're given that distribution. So we know d is a normal distribution with mean 30. So where's my pen gone here? So d is a normal distribution. So this first parameter here, this represents the mean, and the second parameter here represents the standard deviation, or the variance, depending on which way you express that. Okay. So what we want to do for part A, just hopefully nice and straightforward, is just find the probability that a randomly selected employee has a journey to work of more than 20 kilometres. So here we're looking to find, for part A, the probability that D, in this case, is greater than 20. Okay. So how would we do this? Well, what I would recommend, if you don't have one, get a graphical calculator. You'll save yourself so much time and effort on these questions. And the whole kind of course is designed, or the stats part is definitely designed so that you do have a calculator, just to make this a lot easier. Okay. It didn't used to be the case on the old spec. You was expected to use the tables given in the formula book. That's not necessarily the case then. It's more expected that you do use a calculator. So what I'm going to do is I'm going to walk through what I've basically got on my calculator. And you should have hopefully something similar. So I'm using a Casio, I can't remember the model. It's quite old now, but it does the job. So what I get on my screen is I get an option for lower. Okay, so I get an option for lower. I get an option for upper. I get a sigma here. Remember, sigma represents standard deviation, and I get mu. Okay, and mu represents the mean. Now, if you don't know how to get to this screen to actually work out the probability, what I do is I go onto the stat screen, I then click distribution, or DIST, I click norm, and then I click NCD. We don't want MPD, we just want NCD, okay, and then you should get these options here. Now, the values I input here are based on our distribution and the probability that we're looking to find. So in this case, because I'm looking for the probability that D is greater than 20, I've got to decide whether 20 goes into lower or upper. So because D is greater than 20, it doesn't go into the upper, it actually goes into lower. It might seem a little bit counterintuitive, but in a way I like to think of it as the opposite. So if D is greater than 20, then this goes into the lower. So 20 is our lower value. Now for the upper, what we do here is we input a very large value. Okay, this is quite arbitrary, but I just put loads of 9. So 9, 9, 9, 9, 9, 9, something like that will suffice. Now for the standard deviation, we're told that in the question here. So our standard deviation is a square root of 8 squared, which would give us 8. And then for the mean, again, we're told that here, that's the 30. Okay. And if you click enter or execute, what you should get then is P, that's our probability, is 0.894 there. Okay. And if it helps, draw a sketch here just so you can see what you're actually looking for. Okay, so we draw just a rough sketch of our bell curve. It's going to look something like this. Okay, don't have to be perfect, but just so you get the idea. In the middle here, that's our mean. So this is 30. Okay, and what we're looking for is probably that D is greater than 20. So if we say 20 is here, okay, we're looking for everything to the right of this. Okay, and we can see from our, our graph here that this value should be quite large, and we get that here, okay? If you get a small answer, what you've probably found there is this part here to the left of 20, okay, this smallish area here, okay, and that'd be something like 0.106 or something like that, and that'd be what you'd find there rather than the 0.894, okay? But just so you're aware, this is what you should get here. So 0.894 gives us our solution for part A. So for part B, we're asked to find the upper quartile, Q3 of D, okay? So for this, what we're looking for here, again, let's draw another graph, or another bell curve, just so we can see. What we're looking for here is the upper quartile. So the upper quartile will be at the point approximately here where everything to the left of it, this probability, will be equal to 0.75. Remember, the normal distribution is symmetrical about the mean. So here, everything to the left of this would be 50 or 50%, 0.5, and everything to the right of it will be 0.5 as well. Everything to the right of this Q3, this would be 0.25. Okay, so everything to the left of this must be 0.75. So the shaded area is 0.75 or 75%. Okay. So what we're looking to find here then is the probability that D is less than Q3. Okay. And again, the magic of this is we can use our calculator to find this. So now we come back to the stat screen and we click DIST again, distribution. We click norm, but this time we want inverse normal. So it's INV and then a big N, okay, capital N. And this gives you the inverse normal. So the inverse normal allows you to calculate a value here, this Q3, such that we can work it out for a given probability, which is in this case 0.75. And to work this out, all I do then is I have to choose the tail first. So if we put the tail in here, okay, so this is for B, this was for A, okay. So the first thing I've got to input is the tail. So the tail is given by the actual probability here, okay. So the way to, choose whether it's left or right or whether it's center is to look at our inequality. So because the inequality here is pointing to the left, okay, it's a very basic way to think about it, but because it's pointing to the left like that, that means the tail is left, okay. If this inequality was the other way around, so if it was like that and pointing this way, then the tail would be right. For the area, so the area that we're looking to find here is what's given as our probability. So in this case, that's a 0.75. So we put 0.75 there. And then again, all we need to input is the standard deviation, which is sigma, and the mean, which is mu. Okay, and again, they would be the same as part A, so that's 8 and 30. And here now, all I'm going to do is press enter, and what you should get here is a value, which is x inverse, and what you should get is, for Q3, sorry, for the upper quartile, is 35.395918, and clearly we want to round that to something sensible, so what I'm going to round that to here is 35.4, okay, and that's our upper quartile there. And for part C, there's two ways of doing it. You can do it again in a similar way, using your calculator to find Q1. So in that case, all we need to do there would be to change on our calculator. We just need to change the area to 0.25. Or the other way you could think about it is by doing a graphical method. So if we think about part C here, okay, we've got our sketch again. We just draw what this looks like. Again, our bell curve. It's a really bad bell curve, but you get the idea. So this is our mean here, symmetrical about the mean, which is 30 in this case. So we got for Q3 that this was 35.4. Okay. So this distance from the center here, from the mean to our Q3, that distance will be the same from the mean to Q1. So clearly we could work out this gap here by doing 35.4 minus 30 and getting 5.4 and then doing 30 minus this value here because we're going to the left now, so 30 minus 5.4, and in that case what we get is 24.6. Okay, We can do it like that using the symmetry of the graph, because obviously I can just subtract it from 30, or you can just use calculator. Like I said, everything will be the same, but instead of 0.75, you change that to 0.25, because this is what we're looking for here, Q1. Okay, but like we see, only 1 mark, it should be quite straightforward. Okay, so that's the solution there for question 1 here. Hopefully that wasn't too bad. So let's jump into the next one. So this is Edexcel S1, June 2014. Part A is pretty standard. We're just asked to work out a probability. So again, we're going to use our calculator here. So question 7, we're given the heights of adult females are normally distributed with mean 160 centimeters and standard deviation 8 centimeters. So I'm going to define my distribution here. I'm going to use the letter H, but it doesn't really matter. But H seems sensible given we're talking about heights. So H is normally distributed. So our mean here, we're told, is 160 centimeters. So we put 160. And then our standard deviation is A. So I'm going to write that as A squared there. Okay. So now we want to find the probability that a randomly selected adult female has a height greater than 170. So I'm looking here now for the probability that H is greater than 170. Okay. And again here now, I'm just going to use my calculator using the normal distribution and then NCD. Okay. And again, we need to make sure we input the correct value. So straight away, we know what the mean and standard deviation are. So we can input those, so 160 and A again. So here now, we're looking for the probability that H is greater than 170. So because this is greater than, we put the 170 in the lower, and then upper, we just put loads of 9. So something large. And what you should get here, if I round this to 3 significant figures, is 0.106 there. Okay, and that's our solution there. If you get a quite large value, what you've done there is you've gone the wrong way round. So you put minus 99999 in your lower, and then 170 in the upper, and you get 0.894. Okay, so that's the other way around. So just be slightly careful. You should get 0.106. So that was part A, nice and straightforward. Now part B is a little bit more complicated. We're told any adult female whose height is greater than 170 centimeters is defined as tall. An adult female is chosen at random, and given that she is tall, we want to find the probability that she has a height greater than 180 centimeters. So straight away, what you need to be looking out for here is this word, given, or given that, okay, this phrase. This is a big clue, and what this tells us is we need to use conditional probability, okay? So what I'm looking for here is the probability that a woman has a height greater than 170 centimeters. Oh, sorry, 180 centimeters. So the probability that H is greater than 180 centimeters. But we're doing this given that she's defined as tall, and tall is greater than 170 centimeters. So H is greater than 180, given that H is already greater than 170. Okay, so this is what we're looking for here, and this looks a little bit complicated, but it's not too bad. Okay. What I need to think about now is expressing this conditional probability. So I'm looking for the probability that H is greater than 180, given that H is greater than 170. So in that case, we use our formula for conditional probability. So this is the probability that H is basically, how do I explain this? What we're looking for here would normally be the intersection. So H is greater than 170 and H is greater than 180. So I don't know if I quite expressed that mathematically in the correct way, but that's our numerator. So we're looking for the probability that H is greater than 170 and greater than 180. Now, if H is greater than 180, then this first part here will already be assumed. If it's greater than 180, then it must definitely be greater than 170 as well. So our numerator, we can actually just express that as the probability that H is greater than 180. Okay? And for our denominator here, well, we just divide that by the given part here. So that's the probability that H is greater than 170. Okay, so we divide this by the probability that H is greater than 170. So all we need to do here is work out our numerator. We've already worked out the denominator. That's this part here in part A. So all I need to work out now is the probability that H is greater than 180. And again, we just go back to our part A on our calculator, and all I need to change is my value for the lower. Instead of it being 170, it will just simply be 180. Okay, and what you get then in that case is 0.0062. Okay, so to get my answer here, I'm going to do 0.0062 divided by the probability that H is greater than 170, which is 0.106. Okay, and if I input this into my calculator, what I find here is I get 0.0585. Nearly got that wrong. So 0.0585 there. Okay, and that's probably that she has a height greater than 108 centimeters, given that she is tall. Okay, so I can see that part B is a little bit more complicated, and it can get quite tricky. So definitely worth practicing questions of that type. So let's move on to question 3 now. Again, just taking a look at slightly different parts to this. Part A, again, pretty standard, but part B looks a little bit different, and we'll take a look at that in a moment. So part A, here we're looking to find the probability that M is greater than 160. So let's just take a look at the context of this question. So this is a scientist who's found the time taken M minutes to carry out an experiment can be modelled as a normal random variable. In other words, a normal distribution with mean 155 minutes and standard deviation 3.5 minutes. So here now, all I do again is I just express this as a normal distribution, and I input everything into my calculator. So if we define the distribution here, is a normal distribution with mean 155 and standard deviation 3.5 squared here. Okay, so that's our variance, so we'd square that for the standard deviation. So here now, all I'm going to do is basically calculate each one as I go. So part A, I'm looking for the probability that M is greater than 160. So because it's greater than 160, 160 goes in the lower. In the upper, we just pick a large value, so I just input all these. And then our standard deviation, we know that's 3.5, and our mean is 155. And if we input that into our calculator, what we get here for the probability that M is greater than 160 is 0.0765. Okay, and if I run that to three significant figures, 0.0766 there. Okay, so that's part A, 3 marks there. Now for part B, it looks a little bit more complicated. M is between these two values, but it's actually quite easy. All we do is we use our calculator again. And what I'll do is I'll do my interface again, just so you can see what you should be getting here. So if we go back to the NCD screen, what we've got is our lower, we've got our upper, we've got our standard deviation sigma, and we've got our mean mu. So for the lower, that would just be the lower value of this interval, so this 150 here. So 150. The upper will be the upper bound, so that's going to be 157. And then standard deviations and the mean, again, we just take that from the question. So the standard deviation is 3.5, and the mean is 155. And if we press execute on our calculator, so I just input it myself, 157, what you should get here is 0.6393. So 0.63. In fact, I got something slightly different. 0.6396 there. Okay, and that gives us our solution there for the final 4 marks. So that's question 3 done. If we just move on to the very last question here, we've got Edexcel S1 June 2015, and this one looks slightly different again, but again it's just calculating probabilities. So what we're given is this random variable z, which follows a normal distribution, and this is a special normal distribution. This is a standard normal distribution, which is a mean of 0 and a variance or standard deviation of 1. So here we're given 3 events. A is the event that z is greater than 1.1, B is the event that z is greater than minus 1.9, and C is the event that z is between minus 1.5 and 1.5. And we're asked to calculate 4 probabilities. So let's have a go at these step by step. Now this looks complicated, but again, we're just simply going to use our calculator here. So to find the probability of A here, so the probability of A, Well, just by using our calculator here, what we're looking for is the probability that Z is greater than 1.1. Okay, if we know A is the event, that Z is greater than 1.1, we can just simply replace that. And here now, I'm going to simply use my calculator again. Again, my upper and my lower. Well, my lower here will be 1.1, okay, because this is greater than 1.1. So we put that into the lower. The upper will be a large value, lots of 9s. And then for the mean and standard deviation, well, standard deviation is just simply 1 and the mean is 0. What you should get here is 0.136, the 3 significant figures there. Okay, so that's our part A. Part B, or part 2 should I call it, again, just looking at the probability here of B, well, that's the probability that Z is greater than minus 1.9. Okay, and then same idea here, we need to put that into the lower. Okay, and then again, all we do is just press enter. We've got the standard deviation, we've got the mean already inputted. All we need to do is press enter, and if you do this correctly, what you should get is 0.971 there. Okay, so that's part 2. Part 3, just like the last one we saw for question 3, this is where we're going to put our lower as the minus 1.5, our upper as the 1.5. This is the probability being between minus 1.5 and 1.5. And then putting that into our calculator, what we get here is 0.8664. If you do that to 3 significant figures, that will be 0.866 there. Okay, seeing as I've given the other two to 3 significant figures. And then finally, for the last one, part 4 here, we're looking for the probability of A union C. Okay, so this might throw some people, but again, it's not actually too bad. All we're looking for here, all we need to think about is these two events. So A is the event that Z is greater than 1.1, so we want everything that's greater than 1.1, and C is the event where Z is between minus 1.5 and up to 1.5. Okay. So in this case, all I'm saying here simply is that P, or probability, is going to be Z greater than minus 1.5. Okay. If it's A union C, we're just saying everything above that. Okay. So greater than minus 1.5 there. Okay. And all I need to do now is input this into my calculator. So if I do that correctly, all I'm going to get is 0.933 there. Okay, so that's the 3 significant figures. And that gives us part 4 there, and that gives us our full solution to question 6 there for all 6 marks. And that actually brings us to the end of this video. So that's the introduction to the normal distribution, calculating probabilities, etc. Hopefully this video has helped. If you do notice any mistakes or anything that's unclear, like always, please leave a comment down below. There's always a possibility that I do make a tiny error somewhere. But other than that, cheers.